All right, guys, I am going to do the notes for 17.2 for this week, and then my goal is to stop there, and then starting next week, finish through 17, and then through the month of May, do all of chapter 18, which will take a couple weeks, and then do a section of chapter 19, and then I'm leaving you guys a little bit extra on the end that you don't actually have to turn in or anything, but it's kind of important to biology. So I'm just trying to look out for you. We're only maybe one chapter or one lab actually away from doing what I would have liked to do. It's just much more compressed. So here's a review of 17.1, and this was an assignment that I gave you on Monday. So what are the properties of a typical metal? They are shiny, they are ductile, they're malleable, they're good conductors, they're almost all solids at room temperature, and they're very common and useful. All right, how do atoms bond in metallic bonding? So metals form generally either ionic bonds, which we'll talk about next chapter, or metallic bonds. So when they're bonding with another metal, they form metallic bonds, and so all of the elements or all of the atoms of the different metals kind of release their electrons, and then they just grab onto them as they need it. Again, watch the hunting elements video. There's a section about alloys and bells that are that's really interesting. So then we learned about a couple of the groups of metals. The alkali metals are group 1. They have one valence electron. They're super reactive to air and to water. Alkaline earth metals group 2 has 2 valence electrons. They're less reactive, and when we throw them in, say, a fire, they don't burn. So that's why they were called the earth metals. They are not generally found in nature by themselves. They're found in compounds. And then the middle part of the periodic table, so group 1 and group 2 is here, and then the middle part, that middle part right there we call the transition elements or the transition metals, and those kind of transition from a pure metal to a non-metal. But those are most of the common metals that you think. Copper, aluminum, zinc, gold, silver, copper, all of those. Okay. And then there was the question. So that's your brief review of 17.1. 17.2 talks about nonmetals. So we're flipping to the other side of the periodic table. Okay. Questions here are how do nonmetals bond? What are the properties of hydrogen that make it a nonmetal? And what are the properties and the uses of halogens? And why are noble gases non-reactive? Okay, so review. Sublimation is again going from a solid right to a gas without forming a liquid in between. And there's a couple of the nonmetals that do that. And then another word that we'll learn here is diatomic molecule, di meaning 2, and then atom meaning atoms. So these are molecules like oxygen, the one that you're breathing, is O2. It's a diatomic molecule of oxygen. All right, so again, we're over here in the yellow part of the periodic table, and then hydrogen is over there by itself. Again, if you watch the hunting elements video, there was a whole section where they tried to collect all of the elements that were in the human body, and it was kind of funny. So here is your little schnapps diagram over here, okay? Nonmetals are usually gases or sometimes solids at room temperature. The ones that are solid are very brittle, powdery. They're the exact opposite of a metal. Okay, they're poor conductors of heat and electricity because they hold on to their electrons much tighter. Okay, hydrogen is the one weird exception, and if you remember from that worksheet we did a couple weeks ago, this was kind of one of the questions. So 90% of all the atoms in the universe that we found so far are hydrogen. It's really small, 1 proton, 1 electron, no neutrons. Okay. Most hydrogen in Earth is found in water, and hydro from water comes from hydrogen. Hydrogen is unstable by itself because it has 1 valence electron. But hey, if another hydrogen comes over, they have 2 valence electrons if they share. And now guess what? That shell is full. So hydrogen is a diatomic molecule because if it shares its electrons with another hydrogen, its valence is full and it's much more stable. We put it in group 1 because it has 1 valence electron, even though it has all of the qualities of a nonmetal. Some periodic tables actually put hydrogen and helium up above the table because they don't quite fit, but they do kind of fit. So that's why it's in group 1. That's my dog barking. It's all good. So now we're all the way over on the far side. Oh gosh, I didn't mean to pick myself up. I just wanted to move myself. It won't let me move myself. There we go. All right, so now we're almost all the way over on the periodic table. We're one away from the edge. This is the halogen group. Halogen comes from the word for salt. Halo means salt. All of these nonmetals form salts when combined with a metallic or metal element. More on that next chapter. Fluorine, chlorine, bromine, iodine, and astatine are all group 17. Okay, they all have 7 elements or 7 electrons in their valence shell. So they really, really, really want one. And they're bullies, and they will do whatever it takes to get it. Okay, they're super reactive if you find them in their elemental forms. They do also, some of them form diatomic molecules as well, just to fill that shell, because if they each share one of their electrons, then they're full. These are important compounds, halogen light bulbs. They're all toxic. We use them for disinfectants. So like chlorine is in bleach. Iodine we use to clean skin before surgery. And they're all very colorful. Chlorine specifically is this yellow-green color. Bromine is brown, like an orangey brown color. And iodine is actually purple. Okay, so they're all kind of colorful. The other completely non-metal group is called the noble gases, and it's all the way over on the edge. Group 18. All of these elements have full valence shells, and except for helium, they all have more than 2, obviously, but helium is full. So this whole column here, their valence shell is full. They're very stable. They don't really react with each other in nature. Some very clever people have found some ways to make them make compounds, but not really in nature. Okay, and they all have interesting colors, and those neon signs that we make, they're actually all these different gases. Depending on what color they are and how much electricity you put through them, you can actually change what colors they are. Okay. All right, so the essential questions are, how do nonmetals bond? Well, they bond in 2 ways. Well, 3 ways, actually. They form diatomic molecules. I always do this backwards because I'm backwards. They form diatomic molecules with themselves, okay, like oxygen, O2, or hydrogen, H2, or chlorine, Cl2. Or they can form ionic or covalent bonds, which we'll talk much more about next chapter. Try not to stress. What properties of hydrogen make it a nonmetal? Well, it's a gas. Okay, it forms a diatomic molecule. It doesn't really, well, sort of doesn't really conduct electricity at room temperature. So because of its state of matter, we call it a nonmetal, even though it doesn't really fit the qualities so well. What are the properties and uses of halogens? Halogens are group 17. They are all toxic. They're used for disinfectants. They're important in a lot of industrial uses, and they all form salts with metals. Why are noble gases unreactive? Because their outer valence shell is full, so they don't need to share or gain electrons or lose electrons. They're good where they are. Okay, 17.2 questions, which are due, I'm going to say by Friday, 7 through 12, and they are on page 530 in your book. And if you're having problems getting into your book, I posted a new redemption code and a new class code for you to get access to the new textbook, because our textbook expired like a week and a half ago. So that should handle that problem for you. All right, have a good day. Miss you guys a lot.